Hi students, and from here we are going to start studying about the second most important operation in calculus, which is called as the integral calculus. Now, have you ever imagined how an electrical engineer determines the length of power cable needed to connect between two substations? Or how does an architect determines the amount of material required to build arcs, domes, or such type of artistic models? How does a physicist calculate the center of mass of a sports vehicle for ensuring the safety of the driver? Or how does a statistician calculates the average of sets of data to help and develop different marketing strategies for companies? The answer to all these questions is integration. Yes, integration makes it possible. So, this lecture is on indefinite integrals, and this forms the very basis of integral calculus. So let's embark on this wonderful journey of learning integral calculus. Now, if we say that a function is differentiable over an interval, then it means that f dash x would exist, and we can very easily find the value of f dash x through the methods of differentiation. Now let's make a twist. If we have been given the value of f dash x, can we find the value of fx? Yes, we can find the value of fx. And this value of fx that could have possibly given us the derivative f dash x are called as the antiderivative. This very process of finding the antiderivatives is called as integration. It is the opposite of differentiation. Now, integration as an inverse process of differentiation. Integration is the inverse process of differentiation. This is because if we have been given the derivative, then we find the primitive or the original function using integration. So in differentiation, what we do is we have a given function fx and we calculate its differential. But in the process of integration, what we do is we take our steps backwards, and from the derivative of fx we try to find the value of fx. So integration is also called as anti-differentiation. Now we know that the differential of sin x is equal to cos of x. So cos x becomes the derived function of sin x. So if I ask you what would be the integral of cos x, then we can surely say that sin x is the integral of cos x, because the differential of sin x is cos x. Thus sin x becomes the integral of cos x. But we also know that the derivative of a constant function is also 0. So if I have any function sin x plus c, and if I differentiate it, then I get the differential as equal to cos x. So the integral of cos x would be sin x plus c. Now as we see that c is a constant and whose value can vary. So as the value of c is variable, we can have infinitely many antiderivatives. Thus we can say that the integral of any function has infinite many values. So we can say that the functions with the same derivative differ only by a constant. So if I say that we have got two functions and who have the same derivative, then these two functions only differ by a constant. Now if I say that dy by dx is equal to f of c, then if we integrate, we get y equal to integral of fx into dx, and this integral is nothing but equal to f of x plus c. Your c is called as the constant of integration. So whenever we try to integrate any function, so we always add a constant to the obtained value. Thus the integral of fx is equal to capital Fx plus c. Here once again c is the constant of integration. Now let us try to see the integrals of some standard functions. So if we have the function of the form x to the power of n, where n is any number, then the integral is given by x to the power of n plus 1 divided by n plus 1 plus c. So this is an algebraic expression where fx is equal to x to the power of n. Then the integral of x to the power n is given by x to the power of n plus 1 divided by n plus 1 plus c. C is again the constant of integration. If fx is equal to 1 by x, then its integral is given by ln of modulus x plus c. Modulus x, because this value has always got to be positive for ln to be defined. If fx is e to the power of x, then its integral is e to the power of x plus c. The integral remains the same as fx with the exception of a constant. If fx is equal to a to the power of x, then the integral is given by a to the power of x divided by ln a. plus the constant of integration. Now let's see the integral of some trigonometric functions. The integral of sin x is equal to minus cos x plus c. Similarly, the integral of sec square x is tan x plus c. The integral of cos x is sin x plus c. The integral of cos x square x is minus cot x plus c. Integral of tan x is ln of sec x plus c. The integral of sec x into tan x is sec x plus c. The integral of cosec x into cot x is minus cosec x plus c. The integral of cot x is ln of sin x plus c. The integral of sec x is ln of sec x plus tan x plus c, or we can write this expression as ln of modulus of tan of pi by 4 plus x by 2 plus c. And the integral of cosec x is ln of cosec x minus cot x plus c, or ln of modulus of tan of x by 2 plus c. So these were some of the very basic integrals of some very standard functions. Now let us try to see the integrals of some inverse functions. The integral of 1 by under root of 1 minus x square is sin inverse x plus c. The integral of minus 1 by under root of 1 minus x square is minus of cos inverse x plus c. The integral of 1 by 1 plus x square is tan inverse x plus c. The integral of minus 1 by 1 plus x square is minus of cot inverse x plus c. The integral of 1 by x into under root of x square minus 1 is sec inverse x plus c. And the integral of minus 1 by x into under root of x square minus 1 is cosec inverse x plus c. So these were some of the very important integrals and which you need to learn very thoroughly. Now let us try to see the geometrical meaning of indefinite integrals. So if I say that y is equal to f of x equal to 2. So f of x is a constant function and the value of which is equal to 2. Now if we integrate fx, then we get integral of fx equal to 2x plus c. And let us say that this is equal to capital F of x. Now fx is 2x plus c. So we can say that for different values of c, we get different equations of line. Now fx is 2x plus c. So if we put different values of c, we would get different values of fx which are actually straight lines. Hence we can say that capital F of x represents family of lines each with the slope of 2. And so if we put different values of c, we get different members of these family of lines and each having a slope of 2. If we put different values of c, we get different equations of lines. So y equal to 2x plus 2, y equal to 2x plus 1, y equal to 2x, y equal to 2x minus 2 and y equal to 2x minus 4 represent such members of the family of lines. Now we see that the common thing is each and every line has a slope of 2. Now let us say that we draw a line x equal to a parallel to the y-axis intersecting each of these members. Let us say that these points of intersection are a0, a1, a2, a3, a4 and so on. Now a very common thing to note is the tangent at these points of intersection are parallel. Now if we draw tangents to these members at the point of intersection, we see that all these tangents are parallel. Now here we took a very special case that fx is equal to 2. If fx was equal to x, then we would have obtained capital Fx as a family of parabolas. But the condition remains the same. The tangents at all these points of intersection would have been parallel. Thus for different members, we see that we would have obtained different tangents, but the slope of all these tangents is the same. Thus we can say that integral of fx represents a family of curves. So let's try to see the basic properties of indefinite integrals. The first is integral of k into f of x into dx is equal to k into integral fx dx. Your k is a constant. So we can take this constant out of the integration sign and get the value as k times integral fx into dx. The second property is the integral of fx plus minus of gx is integral of fx plus minus integral of gx. That is, if we have sum of two functions, then we can individually find the integrals of these two functions and add them or subtract them up. And the third property is, if the integral of fx dx is equal to g of x plus c, then the integral of f of ax plus b is equal to g of ax plus b divided by a plus c. So this third property says that if we know the integral of any function, then the integral of f of ax plus b is equal to g of ax plus b divided by the coefficient of x, that is a. So these are some of the very basic properties of indefinite integrals which we are going to apply throughout this chapter. Now we have studied about the basic properties, the geometrical meaning. It's time to see the different methods of integration. So throughout this lecture, we are going to see the different ways of calculating the integral of any function fx. The first method is the substitution method. This is the very common method of integration. Here we substitute the value of x by another function, and so it reduces the integral to a very standard form whose integral can be easily calculated. The second is by parts and using isolate technique. Now what is this isolate technique? This we are going to see in some time. And the third one is partial fractions. These are the three most powerful methods of integration, and we are going to see these methods one by one. The first is the substitution method. Now let us see an example to understand this method. Calculate integral of x into sine of x square into dx. So we have to calculate the integral of x into sine of x square dx. So let I is equal to integral of x into sine of x square dx. Now what we do is we make a substitution, and the substitution is let x square is equal to t. Now what we do is we differentiate both sides to get 2 times x into dx equal to dt, or x into dx would be equal to dt by 2. Now we see that in this expression we have x into dx. So we replace x into dx by dt by 2, and so the integral I is equal to sine of t into dt by 2. Now integral of sine t is nothing but minus cos t. So I would be equal to minus 1 by 2 into cos t. Now we know that t is equal to x square. So we again replace t by x square and get I equal to minus 1 by 2 into cos of x square. Thus the integral of x into sine of x square into dx is minus 1 by 2 into cos of x square. So the pattern of substitution is very clear. What we do is we substitute in such a way that the unwanted quantities should go away with dx. So here we made a substitution of x square equal to d, so that we can remove x into dx, and which is equal to dt by 2. And thus the integral reduced to a form which is very easily integrable, and thus we see that substitution makes the problem very easy. Let's try to solve one more example. Calculate integral of x plus 8 divided by x square plus 2x plus 4. Now in this problem we have been given a rational function x plus 8 divided by x square plus 2x plus 4. So let's try to solve this. We write I equal to I1 plus I2. Now we break this integral into two parts, I1 and I2, where I1 is equal to x plus 1 divided by x square plus 2x plus 4, and I2 is equal to integral of 7 by x square plus 2x plus 4. So in the first step what we have done is we have broken down the integral I into two integrals I1 and I2, where I1 is integral of x plus 1 divided by x square plus 2x plus 4, and the other integral I2 is equal to 7 by x square plus 2x plus 4. Now let's calculate the first integral I1, and I1 is equal to x plus 1 divided by x square plus 2x plus 4. Now we make a substitution, and that is we substitute x square plus 2x plus 4 equal to t. What we do is we differentiate both sides to get 2x plus 2 into dx equal to dt, or x plus 1 into dx equal to dt by 2. Now we see that the numerator of this expression is x plus 1 into dx, So x plus 1 into dx could be easily replaced by dt by 2. And so I1 would be equal to integral of dt by 2 into 1 by t, because this expression x square plus 2x plus 4 is equal to t. Now this is nothing but equal to 1 by 2 into ln of modulus of t, because the integral of 1 by t is ln t. Again, substituting back the value of t as x square plus 2x plus 4, we get I1 equal to 1 by 2 into ln of modulus of x square plus 2x plus 4. And we also have to add a constant. Let us say that it is equal to c1. So I1 would be equal to 1 by 2 into ln of x square plus 2x plus 4 plus c1. Here we have taken this out of the modulus sign because x square plus 2x plus 4 is always a positive quantity.